So we're at a point where we need to start building out our enemies AI or behavior tree. Now, I'm using the term AI. I just want to be very clear about what we mean by AI in this context. So this is an image I actually did generate with AI, but it talks about the difference between the two. The current usage of the word AI really, is rooted in something called a large language model, an LLM, where you give it text and then it will take that word and it's going to do some pattern recognition in order to kind of take a giant map of possible things to come up with the most likely next word. It's usually always just the next word, and it sometimes is really bad at that. Like, for instance, right here in this chart. But the next word prediction, right? You give it an input and then it comes with some output using just prediction. It thinks it knows what you want next. It actually doesn't think at all. It just produces that based off of a ton of if-then statements. When we're talking about video game AI, though, we're talking about a much simpler chart where you have the input, which is the game state. All of this has to do with state machines. And the input could be like you have an enemy nearby as illicit, or an enemy health at a certain value, or a timer goes off. And then it's going to use some if-then logic in order to generate some sort of scripted behavior. You have to tell it what it should do at that point. And it will use a finite state machine, just like with animation, in order to determine what it can do or can't do based off that logic. Now, the secret is that large language models are actually really just a massive list of if-then statements. That's it. What we're making is a much simpler thing. And the finite state machine is a pattern that's been around for a very long time as a design pattern. And so we will use this in order to come up with some basic scripted behavior, and you'll get the output of the gameplay. Now, I use that image as I generated that image as a test of AI generation, and as you can see, it's not great. That being said, what we're going to be making is really simple. All it's going to do is just move left and right, for right now at least. All right, so in our content drawer, we're going to go to our content folder, and I'm going to make a new folder in here called AI. Inside that folder, we need to make our AI controller. Just like with our player, when we start the game, we get control of an object called a controller. The player controller is where we set up, who the player is. We need to make an AI controller that will be responsible for controlling the enemy. So, right-click, Blueprint class, and then down here in classes, we're going to search for AI controller. We want AI controller right here. Click select, and I'm going to name this BP underscore enemy controller. Now, because we don't have a player controlling this, we need to define what it can do. And we need to make sure that our enemy is using this controller. So then we're going to do that. We'll go to our blueprints folder, go to our enemies. We'll open up our enemy base. And we'll search for AI controller class right here. And we'll set this to be BP enemy controller. Then after that, we're actually going to want to search for auto possess. We want auto possess AI to be placed in world. We want to make sure this is set to place in world. So if it is in our world, when we place it, it will be controlled. We could also set this to spawned. So if we create something that will generate a bunch of enemies for us, then we want it on spawned, or placed or spawned. But placed in world is fine for right now. We compile and save this. Because we did this in enemy base, our slime enemy will automatically have this. So, again, perks of inheritance. So I'm going to go back to my content drawer. I'm going to go to my AI folder, and I'm going to right click in here. I'm going to go to artificial intelligence, and we're going to create a behavior tree. I'll call it BT underscore enemy. And I'm going to open this up. what is this? Well, a behavior tree it's basically a flowchart, right? We add things to this, and based off of different conditions, it'll go to those different nodes, those different states, and perform certain actions. So we have a graph, and we have a root. So this root for the tree is the starting point. This is where everything comes from. We can define the behavior based on data like the position, etc. And it'll do that using something called a blackboard. And you can see it right down here. It has Blackboard here. Right? What is that? Well, a Blackboard is a specific tool that is built into Unreal's AI engine that handles just keeping track of the different variables that we need access to when using a behavior tree. So I'm going to go to the content drawer, and I'm going to right-click Artificial Intelligence, and we'll create you guessed it, Blackboard. I'm going to call it BB_enemy. BB for Blackboard. So we can store variables that our behavior tree can reference in the form of something called a key. So inside of our Blackboard, here we have our different keys. These keys are basically just variables that let us store some sort of value and reference it inside of our behavior tree. And those keys, we'll be adding some in a second. For right now, we just want to hit save and go to our behavior tree and hit save there as well. In our behavior tree, if we look at the right, we can see, all right, well, this is a Blackboard button. We should be able to switch to the Blackboard mode. We need to actually set our Blackboard asset. So in the details panel, Blackboard asset, I'll set to BB enemy. And now I can actually switch between our behavior tree and our Blackboard right in here. So I don't actually need to have my Blackboard open as a separate thing. I can just do it here to save some headache. So we have the behavior tree set up and a Blackboard, but we need to actually see how this actually works. So we're actually going to go to our, open up our BP enemy controller, go to my event graph, and we're going to delete everything in here. Clear out completely. What we want to do is we want to right click and event on possess. So when our enemy controller possesses an enemy, we want to run a behavior tree. So I'll right click here on do run behavior tree. Connect these nodes here. And for the BT asset, we give it the BT enemy. So anything that has our enemy controller that gets possessed by it will run this behavior tree. And this way we could actually set up different behavior trees for different enemies if we wanted to. File and save. And for this next part, you don't really need to do what I'm doing. Just kind of watch and see this testing that I handle here. So for this next part, you don't have to follow along with what I'm doing here. I'm just going to be demonstrating some stuff, and I'm going to ultimately be deleting it by the end of the video. There are a few parts that you're going to want to do, but I'll let you know when those happen. So here I'm in the test map. It's easier to show this in 3D. So in the test map, I'm going to go ahead and grab one of my enemies. So PP slime, drag that in. And I'm going to have this game simulate. So one thing that we can do when we press play, this plays and we have control of it. Reality, I want to simulate. So if I click the three dots and go down to simulate, now the game doesn't let me control it. It doesn't spawn a player in. It doesn't start the game. It just just simulates the game as if we're not playing it. This would be really useful for testing things like AI behavior. So when we are working, we need to provide something called a navigation mesh, which is a way of telling the game where can our enemy go. So I'm going to go up here at the top, and I'm going to look for navigation, or look for Nav Mesh bounds volume. And I'll place that into my scene. And it can be a little hard to see in the video, but I have this orange box that showed up. Now in this orange box, there's nothing in here. There's nothing that's going to go in here. It doesn't actually do anything beyond outline the area in which our enemy can move. It's a very simplified mesh, and this is one that ignores the complex terrain. So if, let's say we had a bunch of hills and a bunch of really complex things in here, the Nav Mesh is a simplified geometry that is easier to work with and calculate. I'm going to take this and I'm going to scale this up quite a bit. I'm going to make it really big. And I'm going to make sure that my enemy is inside of it. I'm going to grab my cube that I had, and I'm going to also make sure that's inside of it. So I'll have to grab the Nav Mesh bounds volume, even bigger. So that way the enemy and the box are in. Anything inside the box is fair game, but it can be a little hard to see, and we don't really know what this did. But if I press P on the keyboard, it's going to show this big green box. This green box is the Nav Mesh, and it looks at the scene and determined, hey, where can our player move? If I take the box and move it out to the side, right, I now have the Nav Mesh that says anything that's there on the ground works. But I can take this and drag it into my scene, and it will calculate and say, hey, you can't go here, right? And so it'll tell the AI, no, that's an area you can't move. If I take this box and I move it up, eventually that hole in the Nav Mesh gets filled and I can go under this. For the purposes of this demo, I want to have it on the ground because I don't want to be able to actually go on there. So it looks at the level and it defines where the AI can navigate. And then we can tweak the settings and clearly define what it can do. So let's test it out. So I'm going to go to my BP enemy base and go to my event graph. And on event begin play, I'm going to add an AI move to. And I'll connect that here. So this is a specialized node that handles AI, right? This uses the AI controller to move our character. This is not using the behavior tree because we don't have anything in there yet. All this does is just moves it to a point, right? So we need to identify what it should, what should move. Well, the pawn should be self. So I'm going to drag from pawn and I'm going to get self, get reference to self there. We're telling the enemy to be the thing that we move. We can define a specific destination, and I'm going to have it just be the origin, just right to the middle. It's just going to navigate to the middle. We could also give it a pawn or a different target if you wanted to, so we can make it so it always follows the enemy. But for now, let's just go and have it move to the middle. And then I'm going to compile and save. Go back to my test map. I'm going to grab my enemy, my slime, and I'm going to bring it over away from the middle. And so the middle of our level is right here. Right? And if I take this and I simulate, you can see that the enemy is moving towards the middle of the level. In fact, I'm going to go to my enemy base. I'm going to grab the movement and I'll change the speed. I'm going to bring this up for the purposes of the demonstration, 300. And I need to find where the origin is. So I'm going to take this block. So this location to be 0, 0, 0. So that is the origin. It's right there in the middle of the map. So again, let's test this out and see what happens. And it moves to the middle of the map. And it is only moving along one direction because it's currently constrained where it can't move. So I can go back to my character and do constraints. And I can unconstrain it temporarily. There we go. So now it's moving straight towards the middle of the level. there we go. So I know I did a bunch of stuff to make this work for demonstration purposes. Again, make sure you didn't do them. Those are just here for us to show. So now it is moving the enemy towards the middle of the scene. Great. What happens if we give it an obstacle? I'm going to take this and I'm going to put a block in the middle, or block in front of it. What does it do? Well, the point of the Nav Mesh is that it will go around that block because it's analyzing it and reading, well, what's in the way? Well, go around the corner. Which is a really handy tool that you used to have to put together ourselves. So we can make it go around. Cool. But we don't actually want to do it this way. That's the one part of this that I wanted to highlight. Like, this is just a demonstration. All right, so that's going to be it for this video. We have basic setup for movements using an AI navigation. But this is in 3D, so it's not really what we want to do. We want this to work in 2D. But we're going to get to that in a little bit. Again, you didn't need to follow along with this. I'm going to actually have to undo a lot of what I did here anyways. But I did want you to see how this all worked. So that's it for this one. Thanks.